Hello and welcome to part 3 of this MVA course on Windows Server 2012 R2 Virtualization. My name is Matt McSpirit and I'm one of our technical product managers in the Windows Server and System Center division. In parts 1 and parts 2 we looked at some of the scalability and performance and density capabilities, some of the security and multi-tenancy, and also some of the flexible infrastructure capabilities provided by Hyper-V in Windows Server 2012 R2. And we have looked at a phenomenal number of features, capabilities, cool stuff. So I urge you, if you haven't checked those out, go back and check out part 1 and part 2 and then come back and join us. But this is part 3 where we're going to focus on some of the key features and capabilities within this high availability and resiliency section. And why is that important? Well, HA and resiliency really is incredibly important for delivering continuous services to the business. Think about it. You've virtualized your key mission critical workloads. They're running great, they're performing really well, you've got great density, you're getting a big return on investment, but then something goes wrong. VMs go down because a host has failed. You've lost a site. That has a big impact on the business, and we need features, capabilities that can help us circumvent those potential issues, provide a solution if they happen. And that's what our customers have been asking for. They need a robust, reliable infrastructure for that foundation for continuous services, because they want to deliver a continuous service to their internal customers. IT want to deliver a reliable business service. Provide flexibility to ensure that applications are running efficiently at both the OS level and the underlying hypervisor level, but both at the application level as well. We want to simplify maintenance of the infrastructure, ensure that we can protect and ensure we maintain and patch it efficiently without too much hard work, whether we're a big enterprise or a small organization with just a few hosts. We want to be able to provide a solution that in the event of a disaster, we can recover, not just locally, but also geographically. What if I lose a site? What options do I have? What can I do? What can I put in place with Windows Server 2012 and R2 and surrounding technologies? And finally, can the cloud help me here? Can I take advantage of some of the services provided by Windows Azure to help enhance my solution that's on-premise and deliver a more capable and complete disaster recovery solution? And the answer obviously is yes. And we're going to look at some of those key ways that Hyper-V and Windows Server 2012 R2 deliver that through features like clustering, backup, NIC Teaming, something as simple as NIC Teaming to help resiliency at the NIC level within the Hyper-V hosts, replication from virtual machine host to virtual machine host, from site to site, clustering at both the host and the guest level, dual levels of resiliency there. Shared virtual disks to enable new clustering scenarios, and also how we can start to organize and prioritize virtual machines within the clustered environment. All of that cool stuff we're going to cover right now in this session. So let's get on. Let's have a look at some of these key capabilities. Now, NIC Teaming sounds like something so simple. It's an aggregation of physical network adapters, up to 32 NICs, in the box in Windows Server 2012, and provides an extra levels of resiliency should individual NICs fail. So should we lose a NIC, we effectively still have traffic that passes through to the virtual machines because they've been bound to a physical team rather than an individual physical NIC. As I said, we support up to 32 network adapters, configuration and management through the GUI or through PowerShell, but this is only just introduced in the box in Windows Server 2012. Prior to that, it was a third-party solution, so there was always a slight grey area around support. Now it's in the box, it's fully supported by Microsoft, and it aggregates those NICs from a bandwidth, from a resiliency perspective, to provide a better level of resiliency for your key workloads. And we'll go deeper into the NIC teaming in the networking overview within the other MVA course for Windows Server 2012 R2 networking. But there was key things to be aware of. There was multiple distribution algorithms for Windows Server 2012 NIC Teaming, switch port and address hashing. Those were the two, and they distributed traffic depending on which one you chose in the most optimal way. But in Windows Server 2012 R2, we've introduced a new dynamic load balancing mechanism that uses this concept of flowlets to dynamically adjust which adapter of the team that traffic is flowing through. In other words, it's a more efficient balancing of traffic for Hyper-V virtual machines across those physical NICs. And again, you'll learn more about that within the networking section in the MVA course specific to networking. But that's a bit about clustering. That's a bit about NIC Teaming, where we're distributing networking traffic across all of the different network adapters and we're utilizing them for resiliency. But what about resiliency beyond that network adapter? We've clustered our networks, clustered our hosts together in such a way that enables us to provide resiliency to the virtual machines themselves. That's what's known as a failover cluster. We connect our physical servers together. Remember, we called out in the first part that we now support up to 64 physical cluster nodes and up to 8,000 VMs on that cluster. So huge, huge scalability. But in the diagram, you can see that we've got a cluster, one node, 2 node, 3 node, and then up to 64. Obviously can't fit all 64 on one diagram. And they're all connected to some form of shared storage. What you'll notice is that we've got this V on each of the cluster nodes. That V stands for a vote. The way clustering works and failover clustering works is something called a quorum needs to be established. And a quorum is the state of the cluster. The quorum, if we achieve quorum, the cluster is up. If we don't have enough votes to achieve quorum, the cluster is down. What does that mean in reality? Well, we need a situation where we have an odd number of votes. So in our example, we've got a quorum configuration that's called node and disk majority, and each of our nodes has a vote, and the storage, a witness disk, if you will, also has a vote. So that's 64 node votes, 1 disk vote. Total of 65, odd number of votes. What does that mean? Well, it means if I lost a certain number of nodes and I lost all of those votes, if there are more votes up than are down, the cluster stays up. So that's why we need an odd number of votes. We always need to have a side we can choose. So a number of votes up outweighs number of votes that have gone down, the cluster stays up and running. Where this becomes difficult is if we lose a big number of nodes or votes in one big hit. We can get into a situation where the cluster can't decide where necessarily to stay up or stay down. That's why we've introduced something called dynamic quorum, which will automatically adjust the quorum of the cluster to reflect the number of nodes in that cluster that are left over after an outage. So in the example diagram, we've gone from node and disk majority, we've lost a node, but because we're clustered, the VMs that were on that node automatically restart on another available node in that cluster. But notice that we've removed the vote from not only the downed node, but we've removed it from the storage as well, because we didn't want an even number of votes. Think about it. If I'd have left the vote on the storage, we would have had 64 votes remaining. That's an even number. That wouldn't be great. We don't want to be in an even number of votes situation because of the reasons I identified before. If we'd lost half the servers again, we'd be in a half down, half up situation, and that wouldn't be great for our scenario. It wouldn't help us. So we automatically, as part of 2012 R2, we've got a dynamic quorum to change the quorum configuration, but also a dynamic witness to automatically adjust the witness configuration for that particular virtual machine as well, for that particular cluster configuration as well. So we've adjusted those on the fly, and now we're in a node majority configuration and no witness disk having a vote. So we're down to 63 votes with a node majority config. So I urge you to go out and look more, understand more about quorum configurations in clustering. There's far more than what we can cover today. But just know that clustering has got your back in this release, both in 2012 and enhanced in 2012 R2 with the dynamic witness. We've reduced the AD dependencies. So in 2012 R2, you don't have to create the cluster objects for the cluster. The cluster doesn't need to create them. We can create an AD detached cluster. Your nodes still need to be domain joined, but we don't need reliance on AD for the objects or when AD needs to be present when we start up the cluster. That's important because people who want to virtualize their domain controllers on the cluster get into a chicken and egg situation of which one needs to start first. Cluster is starting, but virtualized domain controller hasn't started yet. Cluster starting fails because it can't communicate with domain controller. Now in 2012 R2 and 2012, that domain controller doesn't need to have been started for the cluster service to start. So a great reduction on the AD dependencies there at both the startup and of the object perspective. There's the draining of roles, a maintenance mode, if you will. So I could right-click one of the nodes, turn on drain roles, and the virtual machines would migrate automatically off that node until I turned on the node again. So that's a maintenance mode, if you will, that would normally be exposed through System Center Virtual Machine Manager, but now it's exposed through Cluster Manager instead. So with those of you with smaller environments who haven't got an investment in System Center, you've got that maintenance mode-esque capability through what's known as a drain roles. On the back of that, if I choose to just shut down a node randomly, for whatever reason, maybe I'm just having a bad day and I go on to node 2 and I say, you know what, you're going down, shut down, we'll migrate the virtual machines off live automatically for any that are running so that there's no downtime to those workloads. So if you make a mistake or whatever, then again, we've got you back. That was different from a previous release of Windows Server and clustering where you shut down the VM, it would save state of those roles. So those they'd have downtime. There's better detection of virtual machine networks that are running on the cluster. So if you've got a virtual machine that's attached to a virtual network that's cluster aware, and that virtual network stops communicating, we can move that virtual machine to another physical node where that virtual network path still exists. So again, keeping the VMs communicating and up, continuous services as we said before. There's a better cluster dashboard for enhanced management. And now you can put those clusters on SMB storage. If this was a 2008 R2 diagram on the slide, we would have had to have had iSCSI or fiber specifically called out. But in 2012 R2 and 2012, we've got the ability to cluster VMs that are stored on SMB storage, accessed over the SMB3 protocol. So there's been loads of other enhancements within the clusters, cluster shared volumes, CSV cache for utilizing host memory, for caching certain read-write or read operations, particularly useful for VDI configurations, where you want to store some of the most recently accessed blocks on in RAM effectively, CSV cache, and access them quickly, reducing the burden on the SAN and the need to actually read and write those, read those IOPS from the SAN. So again, multiple benefits. So that's a bit about clustering. But sticking with clustering in general, once you've enabled and built your cluster, you unlock other capabilities that enhance the application level resiliency and performance in some ways delivered for those virtual workloads on that cluster. And one of those is VM monitoring, virtual machine monitoring, where we can mark a service or services within the virtual machine as important. Now this is a clustered virtual machine. You can't do this on a non-cluster because it's a cluster property. But we mark, in this example, we've marked that mission critical service print spooler as important to us, as one we want to monitor from the cluster. And the cluster will then continue to monitor that service inside the VM. So if the VM service fails inside the guest OS, Windows at the guest OS level will restart it naturally. If it fails again, Windows inside the guest OS will restart it again. If it fails again, Windows in the guest OS will normally take no action. That's the default configuration. But at the cluster level now, we will take over. We'll look and say that service is down, we'll try and restart it. And if that doesn't fix it, we'll shift the VM to another node and we'll restart it there. So we've got the capability to restart the app, restart the VM, all within the box within Windows Server 2012 and 2012 R2. It will also trigger an event log item or entry that you can monitor with your monitoring tools like System Center Operations Manager, for instance. And this is extensible by partners. So we provide some of the capability in box that I've described, but partners take that one step further and really showcase some of the key extensions and the level of depth that they can go to within the environment as well. Now, when we think about clustering, VMs in particular, we want to make sure that certain VMs are more important than others, and we want to reflect that in our configuration. So for instance, imagine we have a scenario where we've got our 3-node cluster that we've seen a few times now with some shared storage, and we've got a couple of virtual machines evenly distributed across those 3 nodes, but we lose a node. With failover priority, I can specify that those VMs start in a certain order. So 1, which is high priority, starts before 2, which is medium, or perhaps low priority. So we've got the capability to specify that high, medium, low, or not to auto start at all. You've got that flexibility to define those. That helps us to control startup order when VMs are failing over. And if you've got a situation where a VM is failing over onto a host where there's not quite enough resource to get it started, but it's a high priority VM, we'll actually start to shut down low priority VMs to get this high priority one started. So we're doing some clever stuff there around priority. But what if you've got a situation where you've got some virtual machines that you really need to keep apart. You want to keep them apart on different hosts. And that's where we can start to use Anti-Affinity through Anti-Affinity class names, which is a cluster property that you can configure through script, or through System Center Virtual Machine Manager as an availability set. So you define an availability set and you add the VMs you want to keep apart to that availability set. And that cluster configuration will effectively try and keep, and as we see in the diagram, the orange VMs apart on different nodes. So even though they started together, the cluster will separate them out. We can also start to use affinity rules like preferred ownership to ensure that VMs try to stay on certain hosts as much as they can, and possible ownership where VMs will only run on certain hosts. So you can use this combination of priority, preferred and possible ownership, and affinity, or the anti-affinity class names as the example, availability sets, together to really help control which VMs run where on which hosts and what happens when failover occurs. So lots of granularity that people I think don't appreciate actually exists. It's all exposed through the GUI and in some cases a little bit of script in the example of the anti-affinity class names, which you can configure through VMM, Virtual Machine Manager. But the key task or the key point of all of this is optimal placement, and on failover, again, optimal placement and restart operation. So that's some of our priority and anti-affinity. But how do we keep these clusters up to date? Imagine you've got a 64-node cluster. Do you want to be the guy that patches that one by one, starting at 5 in the evening, ending at probably 5 the following morning after the reboots that may or may not be necessary? No. And that's where cluster-aware updating as an inbox feature of 2012 and 2012 R2 helps you to specifically patch clustered environments, whether they're physical clusters running Hyper-V or other physical cluster workloads, or virtualized clusters, whatever it is, we can help you patch them. They have to be 2012 or R2 clusters though. So this was introduced in 2012. And what it effectively does is cluster-aware updating is an orchestration, if you will, that coordinates the patching and rebooting and movement of workloads on those physical hosts. So for instance here we've got our couple of hosts with some workloads. We trigger a migration first. So once we've scanned the host, so we trigger with cluster-aware updating the host to check its Windows Server update source. So that could be Microsoft Update on the cloud, in the cloud, or it could be a WSUS server on the intranet, on the LAN. So whatever it is, it triggers that host number 1, to go and check. Does it need any updates? So do a scan. Okay, yes, I need 5 updates. Great, okay. Now it triggers the workloads to move off that host. So we've moved any VMs, live migration, off that host onto another available host in the cluster. This empty host is now ready for patching. Cluster-aware updating orchestrates the patching of that particular host, and then when it's finished, reboots if necessary, then brings the VMs back or roles, and then starts the next node. And just coordinates through that, all the way through. Moving workloads around, patching, moving workloads around, rebooting, and so on. And it just does this automatically. You just set it to go, preview the updates, if you're happy with them, go. And you can set this to run on a schedule. So once a month, once a week, however often you choose to patch your physical fabric, it just orchestrates it all. You never need to look at it in terms of your VMs are always moved around, flexibly kept up online and up and running. It's extensible, so you can plug in a plugin within cluster-aware updating that pushes down hotfixes or updates that server vendors have pushed out, for instance. Whatever it may be, you can plug into that and build the configuration that's appropriate to you. So you can really start to customize this. And notice that second bullet point down. It maintains the availability of the cluster without impacting that cluster quorum. So it works with clustering to adjust and manage that cluster configuration that you've defined as optimal for your configuration at all times. So very, very useful and powerful. And as I said, if you've got a share with third-party update files, point it at it, integrate it, and start to patch those as well. But that's all host clustering for the most part. Keeping those Hyper-V hosts up to date, patched, optimally configured, great. And that's going to give you a certain level of resiliency. But if a host fails, the VM is going to go down for a period of time. The time it takes for the rest of the cluster to reassign that VM to another up node and to bring it up and to start that VM through its normal boot process, which may take a few minutes. There are other ways of providing increased levels of resiliency. One of them is called guest clustering, and that enables me to establish, as the diagram shows here on the slide, a configuration where we've got the physical Hyper-V cluster as we saw before, but we've actually built a couple of guest OSs that are hooked onto some shared storage, and they form a guest cluster. So it's like a cluster in VMs on a cluster. And guest clustering typically needs shared storage. And with Windows Server 2012, we enabled a scenario where we would support guest clusters using iSCSI storage, fiber, through the virtual fiber channel adapter, or SMB storage. So iSCSI and SMB, from the VM to the storage, it would go via the virtual network adapters. For virtual fiber channel, the VMs would connect through the virtual fiber channel adapters directly to the fiber channel SAN. Either way, the guest cluster topology was typically restricted to the storage topology you had within your infrastructure. So if you had an iSCSI SAN and that was it, for your guest cluster, you had to use iSCSI storage. That's as far as you got. That was your option. However, it supports live migration, so I can move running virtual machines around that are part of a guest cluster. Think about a SQL always-on cluster, for instance. I could move one of those SQL nodes from A to B. This is also very important to use those priorities and those preferred and possible ownership along with the anti-affinity to keep those clustered nodes, guest clustered nodes, apart, like we were talking about before. There's no better example than a guest cluster for using those anti-affinity class names or those availability sets. Think about it. You don't want a full guest cluster of multiple nodes all running on the same physical Hyper-V host. That's not a great scenario. However, the anti-affinity class names and the availability sets, they're a soft rule. What that means is if there's nowhere else for those VMs to go, then they're going to go on the same node rather than go down. You know, that makes sense. We want to at least keep the workload up and at least give it some kind of capability to provide service to the users. But there's full support for live migration, full support for dynamic memory in those guest nodes as well. But what happens if a physical host fails? Well, if physical host fails, it goes red, and the VM restarts somewhere else through the natural Hyper-V clustering mechanism. So the VM starts up, and then the guest cluster will just sort itself out. There may be some configuration depending on the workload that's guest clustered, but ultimately that VM will restore to its previous state, it will return to its previous state, and the guest cluster will sort itself out with or without any intervention. Hopefully, if it's a powerful or good application, something like SQL, it's going to sort itself out. And the key thing is the users who may have been accessing the downed VM node as the primary before flicked over to the secondary SQL VM node whilst the primary was rebooting after the failover. So the point is, for those users, there was a minimal outage, but they started using the other guest cluster node almost immediately whilst the primary was restarting, and the secondary became the primary. That's all at the application level. That's nothing really to do with Hyper-V per se, but we, Microsoft, fully support guest clustering on top of a Hyper-V cluster, which is slightly different from some of our competitors. The key thing I pointed out here was that we're tied to the storage. The configuration of our guest cluster is tied to whether we've got iSCSI, fiber, or SMB storage for our hosts. That's not great, especially if you're a service provider. What if you've got a customer who you want to provide a guest cluster for? You're going to have to expose your underlying fabric to that customer, as opposed to using virtual disks that abstract a lot of that away. They have no idea where the virtual disk is residing. All they can see is the virtual disk from inside their guest operating systems. Well, we have a solution. In 2012 R2, we're introducing something called guest clustering with shared VHDX. A shared VHDX, a shared virtual hard disk, the new VHDX format, means that guest clustering is no longer bound to that storage topology. So I can present a virtual hard disk file to a guest cluster, and that virtual hard disk file can be stored on a CSV, on a cluster shared volume. So the virtual disk that is shared between the guest cluster nodes is actually residing on your SAN, on a cluster shared volume, or it's residing on an SMB file share. But again, all the guest OSs see are the drives that are represented as virtual hard disks. They can't see through to your underlying storage fabric. The VM itself sees a shared SAS disk rather than a SCSI disk that it would have seen in the past, and an unrestricted number of VMs can connect to a shared virtual hard disk file. It's utilizing the SCSI 3 SCSI persistent reservations that many of you may be familiar with from physical clustering of Hyper-V, and one of the requirements and one of the checks that's actually made when you build the cluster. And as I said, that VHDX needs to reside on either CSV or file-based storage from a production perspective. And those virtual hard disks can be fixed size or dynamic. So you've got a bit of flexibility and thin provisioning there as well. So it's really providing you with the flexible choice with that new shared VHDX capability. And we've got a quick demo of that. So let's take a look at how easy it is to start to use shared VHDX to build and present a virtual disk to multiple virtual machines simultaneously. So let's take a quick look.
Okay, so what we have on the screen here again is our Windows Server 2012 R2 Hyper-V host and a number of Hyper-V virtual machines that are running on this particular host. And to demonstrate and explore some of the capabilities of this shared virtual disk along with guest clustering, I want to first open up some of the virtual machines that we've got actually already built in the environment. We've got FS01 and FS02, and they're actually a pair of file servers which have got a number of shared virtual disks attached to them. And if we look at the settings of FS01, you'll see that actually if we scroll down attached to the SCSI controller, you'll find we've got a number of disks attached. And if I expand, they're all identical from a configuration perspective apart from the name, but if I expand one of these out, you'll see in the advanced features that not only can I enable quality of service, which we looked at earlier on in one of the earlier demonstrations, but I can actually enable virtual hard disk sharing. And I would do this on a particular virtual disk and then also attach that virtual disk to another virtual machine as well. And without this tick box enabled, you're not going to be able to actually perform that task. You must attach it and tick this box, or you can obviously drive this through PowerShell as well. Now, one key caveat and key piece of information is if you're going to deploy this in a production environment, for this to be enabled, this feature, the virtual disk needs to reside on either block storage running cluster shared volumes within a clustered environment, or running on a clustered file server for resiliency. This isn't just supported on dropping this virtual disk on DAS storage, so something to be aware of there. Now we've got our 6 disks attached, and they're attached similarly. If I go into the properties of FS02 and look at the settings here, you'll see they're attached here as well. And if I bring up the advanced properties of one of them, or advanced features, the tick box is enabled there as well. And it says this is typically useful in virtual machine clustering scenarios, where you want to build a guest cluster for whatever workload that requires shared disks, whether that's an additional workload on top of Windows Server, or that's a core Microsoft Windows Server cluster. Either way, let's have a look inside the virtual machine and just see what it looks like from a File Server 01 FS01 perspective in disk management. You'll see we've actually got a number of the disks that are actually attached, unallocated, no volumes at this point, but they're seen in FS01, and if I come out of there and open up FS02, you'll see they're seen identically here as well. And there's no real restriction on the number of virtual machines that can be attached to a shared virtual disk. So we've made this pretty flexible, but the performance is still very strong and very high for those key clustered workloads. So let's come out of there, because there's no real settings outside of those that we need to adjust within Hyper-V. So really we want to focus on how we start to build a guest cluster within this environment, utilizing that shared virtual disk. So let's take a look at how we do that now using Failover Cluster Manager. So first I'm going to open Failover Cluster Manager. You'll see currently that we're not actually managing any clusters at this point with this particular instance of Failover Cluster Manager. So I'm going to go to Create Cluster. And it's going to prompt me and say, okay, here's a wizard to actually go through and create a cluster of some type. Now in this case we're going to use a couple of those file server VMs, FS01 and 2, and you would want to validate your configuration before building. So I'm going to enter FS01, FS02 and click Add, and it's going to go away and it's going to verify and validate those that the domain joined, they've got the relevant settings and everything's configured correctly. And we'll go Next. And now it's going to ask me, do I want to give this cluster a name? So I'm going to choose a particular name within the environment. In this case I'm going to choose FS Cluster 02. I'm going to type address 192.168, and I'm going to choose one on this particular subnet because that's the subnet that the cluster VMs in this case, but the cluster OSs are already on. So I'm going to choose 96 as a random number that I believe is not in use at this point. We'll go Next, and it's going to check and see if that's applicable. And it is, that's fine. And you'll see here this tick box, it's going to add all eligible storage to this particular cluster, which is great because it's going to bring in those shared disks where appropriate. And we'll go next. And you'll see it's now forming that cluster, it's building the relevant objects and assigning the IP addresses from an Active Directory perspective so we can communicate and everything works as expected and efficiently. And now it's going to bring all of that clustered resource, storage, networking, everything online, ready for this clustered workload. Remember, this is a pair of virtual machines that we've actually created here that we've clustered to form a new file server cluster 02. So that's been successful. A couple of pieces of information and warnings relating to our disk, and we'd probably have to do a little bit more formatting to create and format those partitions to be used by the cluster successfully. So that's an extra step that we'll go through. But the key thing here is, within a couple of clicks, within a couple of configuration steps, we've able to actually build out a file server cluster. Remember, this is a pair of VMs that we've clustered here and presented some shared storage through to the cluster, and you'll see that there's a number of disks that have been presented. These are cluster disks, so it has to be recognized on each node of the cluster to be applicable to this particular environment. And it's assigned currently to available storage, our two cluster nodes inside the virtual machines, FS01 and 2, and you'll see that very quickly we were able to build that out. Now from here I can add additional storage if need be to each individual node in the cluster, and then that will appear as available storage for the cluster. And I can also build clustered storage pools. So hopefully what we've shown you there is a very quick look at just how we can build a guest cluster. In this case it was a file server cluster, but it could have been a cluster that was running a key enterprise workload. The key point here is it was very easy to utilize that shared VHDX file, present that to multiple virtual machines simultaneously, and then cluster them at the virtual machine guest level. And with that, we'll go back to the slides.
Okay, welcome back. Hopefully you found that demo useful. It's key innovations like that that are helping our customers and our partners build new scenarios within their IT environment that they've previously been restricted upon. The example of having to be restricted to your storage topology versus using the shared disk is a good example. It opens up new opportunity, particularly for service providers as an example. But what about protecting our key resources? What about how do we start to back up our stuff? In Windows Server 2012 and subsequently in 2012 R2, that incremental backup, that Windows Server backup, provides a small business, a small medium-sized business with host-by-host backup capability that's incremental, it's space efficient, it's VSS aware, and enables me to back up my environment in a way that is easy to manage, cost-effective, and is Hyper-V aware. No backup agents inside the virtual machines, it's just the delta changes, so it's saving space, saving size, and it's lowering the cost of backup. So when we're taking the first backup on the first day, it's a full backup. Then we're starting to incrementally back up the virtual machines. Just the key differences. We're backing up a day on each day, just the delta changes, and subsequently we can restore from a number of recovery points, but without consuming huge amounts of space that we would have through full backups at subsequent points in time. So a lot of flexibility, ease of use, and it's in the box with Windows Server 2012. But it doesn't give some of the scalability of backup that you would get with something like a System Center Data Protection Manager, for instance, which is scaled across lots of hosts, lots of virtual machines. So this would be very much suited to smaller environments, branch offices perhaps, or customers who've got a small number of servers. However, a lot of customers back up to local disk as that short-term repository, and some still back up to tape. But other organizations are starting to evaluate other locations, perhaps cloud-based services that they could harness to actually provide that backup repository. And Windows Azure Backup as a solution for that is a great option for small businesses, mid-sized businesses, branch offices to send their backups to the cloud. So with an agent installation and a bit of a configuration with a certificate, and a subscription to Windows Azure Backup, obviously, where you need to sign up, credit card, etc. That simple installation, simple configuration allows you to use the Azure Blob storage as a repository to put your long-term archive backup stuff. So you can push that up to Azure, not only can I use it with the core Windows Azure tools, but if I'm using third-party backup services, I can integrate that as well. So I can start to really provide an offline or off-premise backup solution that's integrated with Windows Server and Windows Azure Backup. And as it calls out, reduced cost for backup storage, it's in the cloud, it's resilient, there's options for integration, and it's great for small businesses, branch offices, and departmental business needs. So you've got a good flexible solution that's integrated, but again, it's on a host-by-host basis. So that's why it's really suited for small businesses, branches, and departmental needs, rather than the complete infrastructure being backed up to Azure. But it's allowing you to flexibly back up just those Delta changes up to Azure on a scheduled basis. But that's all great from a backup perspective. But as we know in the real world, if you lost everything, restoration from backup can be a timely experience, as we all know. Restoration from tape, even more so. Is there a better way? Is there an alternative way to have a faster time to recovery in the event of a disaster? And the answer is yes. Because with Hyper-V Replica, which is an in-box solution to provide business continuity through VM replication, we can replicate in a cost-effective way with in-the-box capabilities from site to site our virtual machines. So in this case, I enable Hyper-V Replica on a VM by VM basis. The VMs begin replication. Now that initial replica, I can choose to send now, later. I can choose to ship via media. I've got those flexible options. So say I'm sending a lot of virtual machines, I'm sending them over a really poor link, I might want to ship them. Or if I've got a backup that I can restore on the target site, I could use that as my target and then replicate onto it. Whatever I've got the flexibility to do. And because this is software-based replication, notice in the diagram, I'm going from an environment that's got clustered storage, SAN, to an environment that's using SMB storage. Doesn't matter, I've got that flexibility. They could be going from storage vendors that are different, server vendors that are different, network vendors that are different. It's completely agnostic. As long as I can get there, I can do it. I can secure the replication across the network with certificates. And now in 2012 R2, I can configure the replication frequency. 30 seconds is the lowest I can go. And these are options, they're not sliders. So 30 seconds, 5 minutes, or 15, depending on your business needs. 30 seconds is near synchronous replication that you pay a small fortune for. When you think about storage replication, you think about the links, the things you need to put in for replication, for synchronous replication, the costs just spiral. This is every 30 seconds we're sending the changed data across the wire, and this is inbox technology. Phenomenal capability for businesses of all shapes and sizes. So you choose the one that's most appropriate for you. We're just sending the delta changes after that initial replica as demonstrated in the diagram here. And best of all, because this is all Hyper-V aware, when you're migrating your VMs all over the place, as we've shown with live migration in the previous part, Hyper-V Replica is aware of that sort of stuff. So when you're moving VMs around, you know what? Don't worry. Hyper-V Replica will still keep up with you. You can move stuff around and we'll still carry on replicating the VMs all over the place. So just don't worry. It's easy to configure through the GUI, through PowerShell, and it's flexible. But what we've talked about there is from site to site on a VM by VM basis. There's no VM charge. It's just literally you turn it on and you start replicating your VMs. But what if I'm a service provider and I'm replicating my customers' VMs to my site? What if I have a problem? Do I not need a second site? Can I replicate my customers' VMs that they've replicated to me onto the next site, my DR site, if you will? And that's something that was introduced in 2012 R2, and it's called extended replication. Because upon site failure, yes, we can start our VMs on the second site, but if we lose the second site, extended replication gives me an extra level of resiliency. Once we've initially replicated the first time, so from primary to secondary, i.e. SMB customer to me, my primary site, their DR, that same VM that I've been replicated, I can right-click, enable extended replication, and start to replicate from my site onto my DR site. So that customer's VM is now replicated in 1, 2, 3 places, or it's at least in 3 places. It's replicated to 2. It's replicated to a tertiary site. And again, the flexibility we have to replicate to different hardware, different network hardware, different storage hardware, in this case DAS hardware, Just gives you complete flexibility. What more could you ask for? Complete flexibility, a chained replication from A to B to C. You can configure the replication frequency again in this replica step, but it's only between 5 minutes and 15. You can't choose 30 seconds for that second replication, just 5 or 15. And you can only replicate what has been replicated already. So if you replicated a VM with 2 disks before, same again from site B to site C. But it's really useful for scenarios like SMB, through to me, the service provider, through to my DR, which might be another one of my sites or whatever. That's Hyper-V Replica. Really powerful, really cool, flexible capabilities, but it's enabled on a VM by VM basis, which might take me a little bit of time to configure. If I'm good with PowerShell, or I've got some kind of automation tools like System Center Orchestrator, I better get started and I can put together a runbook that automates all of that. Great. But not all of our customers are in that luxurious position. They may need to think about other ways of how they can orchestrate failover, or they may want a more centralized solution to have visibility of both of their sites and orchestrate failover at group levels or cloud levels. And that's where Windows Azure Hyper-V Recovery comes in, or Hyper-V Recovery Manager. That is a cloud service that is in Windows Azure that you can register for. Once you've registered and set up the initial configuration, Hyper-V Recovery Manager in Windows Azure communicates with System Center Virtual Machine Manager on each of your sites. So you've got VMM managing your Hyper-V hosts on one site and VMM managing your Hyper-V hosts on your other site, your DR site. And you've established your clouds, which enable you to group virtual machines. And you're replicating at the cloud level. Important note, you're not replicating your VMs to Azure. You're replicating them from site to site. Azure is just that communication channel between your VMs. It just needs to know what the VMs are, what clouds they're in, just a bit of information about them. It doesn't know what's in the VMs, it doesn't contain the replicated data. All of that stuff just stays on your premises and wherever you're replicating to. Service provider, another one of your sites, whatever it may be. But you're protecting those important services by replicating. So you're even setting up the replication through Azure Hyper-V Recovery Manager. So if you've set up no Hyper-V Replica so far, you point it at your clouds, you enable the clouds, you define your recovery plans, which are like the phased steps of what you want to recover. So for instance, you might want certain VMs to fail over before others. You may want a stage where you have a manual task that some person has to perform. You may want to include a couple of scripts that have some very specific functionality. So when things fail over, it's all done in an orchestrated way. And what's important with Hyper-V Replica and Recovery Manager is you can test failover in a non-disruptive way. You can do a planned failover. So if you know there's an impending disaster, you can fail over. And you can do an unplanned, obviously, when you've lost one of the sites. But Azure is that eye in the sky on both of your sites. So that's not going to go down. So from the perspective of looking at both of your sites, you don't need a third site of your own to act as that middle view to both of your sites that are important to you. So you can use Azure for that. In addition, when we think about Hyper-V Replica and some of the granular configuration changes you can make, I can set up a failover TCP/IP settings. So for instance, on my primary site, if I'm not using things like network virtualization, when I want to fail over, I'm going from my primary site, which is all my VMs are on a 192.168.10.x network. But when they fail over, they need to be on a 10.10.10.x network. We can configure all of that so that when the VMs fail over, the IP addresses are automatically injected, and when the VM comes up, it's got the right settings that it needs. Obviously, that applications may be depending on certain IP addresses, so network virtualization makes that a lot easier. Remember from the previous module, you don't need to re-IP address your applications and workloads and operating systems when you're using network virtualization. But Hyper-V Replica is the engine of this replication. Should you want to fail over between sites, that's orchestrated from the Azure console. I mean, you could do it from your smartphone. You could do it from any tablet. Anything that's got a web browser, you could do this from. The replication channel is just between the sites. As I said, it integrated with the scripts, and if you lose a site, we'll communicate with Hyper-V Recovery Manager and we'll trigger the failover onto the second site. Extremely powerful, orchestrated through Azure, really effective, simple to set up, and harnessing the engines that you've got on premise. Remember the Hyper-V Replica that we've looked at and explored. So let's take a look. let's take a look at what this looks like in action. Let's explore some of these replica capabilities and how it all fits together to enable us to fail over between our different sites or our different hosts. So let's take a look at Hyper-V Replica and the surrounding technologies in action.
Okay, so what we have on the screen here in front of us is our regular Windows Server 2012 R2 Hyper-V host. And actually this particular host, we're actually managing a number of different hosts from the same Hyper-V Manager console. And we want to take a look at some of the settings, some of the capability and what the experience looks like around VM replication, which is in box with Hyper-V Replica in 2012 and improved in 2012 R2 Hyper-V. Now the first thing we need to do on our hosts is select the host, and in the Hyper-V settings we need to make sure that this particular server is configured to send and receive replicas. So we choose our authentication on our port that we're going to actually use to send the traffic, and we choose a location of where we can store the virtual machines when they've been replicated to this particular server. And we can choose to allow replication from any server or a specific server within the environment if we want to lock it down a little bit more. And once we've done that and we've enabled our replication on our particular server, we can then start to replicate a particular VM. And I'm going to right click this particular VM, I'm going to enable replication, and that's essentially going to start the replication wizard. And all of this could be driven by PowerShell, but in this case I'm going to go through just through the UI. And I'm going to replicate to another server in the environment, Hyper-V 05, so from 1 to 5. And firstly I'm going to choose my connection parameters, and these are chosen for me based on the sending host and the receiving host and what options are selected within their individual replication settings. They're both using Kerberos port 80, that's what I'm going to use here, and I'm going to choose to compress any data that's replicated across the network. Remember, Hyper-V Replica is just literally replicating the changes after the initial replica, so we're just sending the changed blocks of data across the wire from source node to target node. We'll go next to choose virtual disk, and I could choose more than one if I've got multiple virtual disks attached to a particular VM, or I could choose to exclude certain virtual disks for a particular VM. Now something that was new in 2012 R2 that we called out earlier was this replication frequency. In 2012 I could just have 5 minutes, it wasn't an option I could select. Now I can choose to replicate every 30 seconds for near synchronous replication, or relax it a little bit and replicate every 15 minutes. I'm just going to choose every 5 minutes for now, but those are the choices I've got. It's on a sliding scale, it's a one choice or another or another. So I'll go 5 minutes and I'm going to go next. And now it lets me say, okay, do I want to just keep the last replica that's created every 5 minutes? Or do I want to maintain additional recovery points, which will use a little bit more storage and processing power to maintain and create those, but that gives me points in time where I could go back to it at a later date. So for instance, if I chose to create additional hourly recovery points, not only could I go to the latest point in time midway through an hour, but I could go back to an hour ago or 2 hours ago or 3 hours ago, on the hour, every hour. So that's going to enable me to provide that little bit more granularity and also integrate, if I want to, with VSS within the guest for application consistent snapshots and when we're restoring those virtual machines on the target site. But I'm going to go just the latest for now. And I'm going to choose the initial replica to send over the network. So I'm going to replicate right now versus sending it via external media if I'm really struggling with that bandwidth to get that initial, in this case 9 gig over the wire. Or alternatively, I could use an existing machine that's already over on the other side that I could start the replica onto, and I can choose my replication schedule now or sometime in the future. I'll go next. And that's going to confirm all of my settings, and I'm going to click finish. And that's going to go away and start to send that initial replica, and that's going to take a little bit of time to get that, in this case, 9 gigabytes or so across the network. So let's have a look at one I've already replicated, VM01. And if I scroll at the bottom of the screen here in replication, you'll see it's primary replication mode, and we'll touch on what that means in a minute. Replication's enabled, yep, health is good, and it's replicating from node 1 to node 5. And if I right click and look at replication, you'll see I've got a couple of options here. I've got a planned failover. Somebody has told me there's a disaster coming, and I can shut down my VM cleanly, replicate the final change blocks, and then start the VM on the second site using this planned failover option here. But I need to have the virtual machine shut down to begin with. Now I'm going to look at that in a minute, so I'll come back to that. I can pause, view health, or stop replication. But I'm going to go into the VM settings while we're here. and look at the network adapter, expand, and now because this VM is protected by Hyper-V Replica, I've got this failover TCP IP choice that I've got that I didn't have before. And this enables me to configure the static IP of the VM that when failed over to the second site, these are the IP settings that will be used. So this enables me and provides me with a very powerful alternative to manual re-IP addressing if I'm failing over into a site where this VM's network settings don't really match the surrounding infrastructure. So this enables me to change those settings right here. So I'm going to cancel out of there. I'm going to shut down this VM. In fact, I'm just going to turn it off because that's a little bit quicker. I'm going to turn that off, that's gone. Replicating final changes, and I'm going to right click and do a planned failover. And that's essentially going to plan to move the virtual machine and execute the move of the virtual machine from site A to site B. Now I can choose to reverse the replication direction after failover as well. So that's useful if I'm wanting to make sure that at a later date I can fail back to my primary. So I'm going to go failover, and all of those checks have been made successful, and now it's starting the virtual machine on the second site. In this case it's just another Hyper-V host within our environment. So I'll close that out. It's off on this site. Let's go to Hyper-V 5 or pretend that's on other sites, and you'll see VM01 is running on this environment. Primary is 5, secondary is 01. So secondary is and it's replicating back. So we've got that capability now to ensure that if I want to fail back the other way, I can do that. Now, that was a simple primary to secondary example, but what about a virtual machine that we want to replicate that a little bit further? Now on the second site, this SCAC01 VM that's currently running on primary on Hyper-V 01 and is sat on secondary as that replica copy, I can right click the replica, click replication, and you'll see I have a couple more options. I have the option to failover. Why doesn't it say planned failover here? Well, that's because it's already running on the primary site. So we're not in a situation where we need to do a planned failover from the second site. This would be very useful if we lost the primary site. And we're not in a planned situation here, we're in a I need to restore my VMs quickly and efficiently. So the failover option is very useful. Test failover, as the name suggests, effectively creates a copy of the VM and spins it up in an isolated network that you define that enables me to actually test my DR plans without actually having to impact the primary running version of that particular workload. I can do the pause, view health, and remove the replication if need be. But here's a new option that was introduced in 2012 R2, extend replication. So this enables me to walk through a wizard to extend replicating from primary to secondary, and then secondary onto a tertiary location, a third site. So I'm going to go next. I'm going to type in the name of another replica server that I can replicate to. It's going to verify that's okay. Fingers crossed. And you'll see here that it's not actually allowing me to do that because it's not configured to receive replication. So that's an example of an error we'd get from a host that's not actually configured appropriately. So I'm going to make sure I enable that particular feature for this target. I'm going to choose my default locations. I'm just going to choose I'll just choose one of the storage volumes here. This is a quick wizard. Yep. Make sure we enable the firewall settings, in this case port 80, and that, as quick as that host is now configured, ready to receive replica. So that's a good trigger there. If you do try and do this to a host that's not configured, that's the error you're going to get. So we'll go next, verify config, and we're good to proceed. And the similar kind of settings you saw before. Notice now that I haven't got the 30-second option. I've only got 5 minutes or 15. So from primary to secondary, we've got 30 seconds, 5 minutes and 15. From secondary to tertiary, we just have 5 minutes and 15. So I'm going to choose 15 as this is our kind of off to DR site type configuration. I can maintain the latest recovery point here, but it's reflecting some of the settings and choices that I had from my initial choice of replication. I'll go next, send initial copy over the network again, same kind of options, next and finish. Now I'm not going to do that now, I'm not going to extend replication in this example, but that was a very quick walkthrough. All of this can be driven through PowerShell, but hopefully that gives you an idea of just some of the core replication capabilities that are built in to Windows Server 2012 R2 with the Hyper-V Replica technology. And with that, I'll go back to the slides.
Okay, welcome back. Hopefully you found that demo interesting and exciting. It was one of when we introduced Hyper-V Replica in Windows Server 2012, it was one of the most exciting areas that customers just, wow, that's phenomenal. That's in the box. How much do I pay for the VMs? How much? Nothing. It's just in the box. It's easy to configure. It's PowerShellable. It's scriptable. And now we've seen how it's extended and been enhanced in R2 and with the Azure Recovery Manager, Hyper-V Recovery Manager. And they're just some of the areas of innovation that we've built around HA and disaster recovery and business continuity. But what other areas we've been innovating in? Well, there's a couple of other areas that we've categorized within this segment called virtualization innovation. They didn't really fit in some of the other segments, but they're important to call out as tools and features that just could make your life that bit easier. From a user experience perspective, potentially from a performance perspective in some cases, from a security, from a usability perspective, as we said. One of those is called Generation 2 virtual machines. It's like, what is a Generation 2 virtual machine? I didn't even know we had a Generation 1. Yes, Generation 1 virtual machines are the ones you've grown to know and love with Hyper-V. You can still create Gen 1 virtual machines on Hyper-V 2012 R2, but you can also create Gen 2. Gen 2 are specific to Windows Server 2012 R2 Hyper-V. They're not compatible with any other version of Hyper-V. And the guest OSs that will run in a Gen 2 virtual machine are Windows Server 2012, Windows Server 2012 R2, Windows 8, Windows 8.1. They're the only ones. But these are VMs that are built with optimized software-based devices. You say, well, what, a more virtual machine? Yeah, I suppose in a way. If you look in a Gen 1 VM, you know, go in your environments. If you've got Hyper-V 2008 R2, 2012, open up Device Manager in one of your VMs and scroll through some of the devices that you may see that aren't called Hyper-V synthetic blah. Have a look at some of the devices, the IDE devices that you'll see in there, and you'll see there's still some emulated devices. Gen 2 virtual machines are purely synthetic software-based devices. They're a more virtual device, if you will. And they're things like synthetic NICs that now support PXE booting. Many of you may have tried to PXE boot a virtual machine only having had the synthetic network adapter and then been told by somebody or by the internet, you need the legacy NIC. There's no legacy NIC in a Gen 2 VM. It's pure synthetic virtual NIC that supports PXE booting. So it's an optimized virtual NIC for PXE booting as well, which means if you're using VDI scenarios that use PXE boot, great, you can utilize that. Hot add of CD and DVD drives. Dynamic storage. We've got UEFI firmware. So UEFI BIOS that we see on modern systems now, laptops, desktops, servers. That's inside the virtual machine. So we moved away from that traditional BIOS to a UEFI firmware, which supports things like secure boot. So greater levels of security. That removal of those extra devices within the Gen 2 virtual machine means a reduced attack surface, and things like the virtual SCSI, so virtual IDE goes away. All of your boot drives, all of your drives now attached to virtual SCSI, which means we can online resize all drives, better performance, better boot times, faster OS installs. All of those are benefits of going to this new Gen 2 model. And we support now GPT partitioned OS boot disks that are greater than 2 terabytes if you have that need. All of that again is unlocked by UEFI. So there's loads of stuff coming, but is it right for everybody? Well, what I said earlier may restrict you. Windows Server 2012 VMs, 2012 R2 VMs, guest OSs I'm talking here, Windows 8, Windows 8.1. Not Windows 7, not Windows Server 2008 R2 in the guest. They're going to have to be Gen 1. Can you convert between Gen 1 and Gen 2? Nope. Once you make that decision, that's an architectural decision. You've made it. So think carefully about whether it's going to be right for you or not. There's loads of other material on the web around Gen 2 in TechNet, so I urge you to take a look. There's plenty of information at TechEd as well that we talked about. But Gen 2 really is a cool way of enabling certain scenarios. The PXE NIC is a good example, the VNIC, the boot from virtual SCSI, the improved with secure boot and security. But it's just one of those areas where we're going to push this further forward as we go forward to make things better from a virtualization perspective. And from a usability perspective, something called Enhanced Session Mode gives you the richest experience for when you're double-clicking that Hyper-V VM and the VM Connect window pops up and you're used to connecting that way rather than RDPing into the virtual machine, this enhanced VM Connect or enhanced session mode gives you things like audio of VM Connect. So for certain scenarios on Windows Client Hyper-V or certain server Hyper-V scenarios where you've got it perhaps on a workstation, so you get audio even through the VM Connect window without needing to RDP. Copy and paste between host and guest. How many people have asked for this? I just want to drop a file. Great, now you can do it. Redirecting smart cards. This is all over the VM Connect window, not RDP manually into the VM. Remote desktop over VM bus. What is that all about? Well, VM bus is a communication channel that Hyper-V uses with the VMs. Remote desktop over VM bus is using the remote desktop capability to RDP in, even if your VM is network disconnected. So we're able to provide that functionality that even if a VM has been disconnected from that Hyper-V host, we can still RDP into that virtual machine. So that's pretty powerful and very, very useful. This is enabled on Client Hyper-V. It's disabled by default on server, so you'd have to enable that. And live migration, all of that cool stuff works as you'd expect. But this enables me to have a richer, more streamlined experience, and the copy paste is just fantastic. You know, right from VM Connect, just drop a file, boom, in it goes. And again, there's loads more on TechNet about the deep technical of how and why this works. So I urge you to check that out. And there's also an upcoming virtualization white paper that you'll be able to take advantage of as well, that will detail all of this in a lot more depth. And finally, think about service provider. Think about a scenario where you've got a Hyper-V host and you're deploying new VMs all the time and you've got to activate them. Do you want to put your product key inside that VM when that VM is being used by customers who aren't you? Maybe not. Do you want to be manually adding the key each time? Yeah, you could use it as part of your build process, but you may have to also have some times when you manually install a key. No, not really. Automatic VM activation, or AVMA, is a new way in Windows Server 2012 R2 of activating VMs, 2012 R2 data center VMs, on an activated host. So let me walk you through the process. You've got a Windows Server 2012 R2 data center host activated with a normal license key. The customer who you're virtualizing for in this service provider scenario, doesn't matter. They're never going to see that host. They're never going to see that particular key anyway. However, Windows Server 2012 R2 VMs are created with the AVMA key that Microsoft provides you injected into the build. This is a standard AVMA key that everyone will have access to. However, on startup, that VM checks for an activated Windows Server 2012 R2 data center host. If it sees one, the VM is good to go. If it doesn't, that's not going to happen. All of this is configured automatically on the host layer, so the guest device activates, won't recheck again against the host until the next reboot or after 7 days, so it's continually polling. So we're ensuring compliancy, but without too much management overhead. Reporting and tracking of all of this is built in. You can activate VMs in remote locations without internet connectivity. Remember, the VM is checking against the host. The VM does not need internet access. So that's very useful with environments where those VMs need to be isolated from the internet, but still need to be activated for ongoing compliance. It works with migration, it follows the VM around, there's no problem there, and it's on a VM by VM without needing to manage on a VM by VM basis. You deploy your build with the key already embedded, and when that VM starts up or activates for the first time, it's going to activate against the host. So it's just little key features like that that are going to make certain organizations, certain scenarios that bit easier, or their lives a bit easier. So there you go. Virtual machine activation, session mode, the Gen 2 VMs, some cool innovation on top of all of the other innovation in scalability, performance, density, flexible infrastructure, security, HA and resiliency. And that really brings us full circle to the end, to our summary. And we've covered a hell of a lot across these 3 key parts of this course, or across this virtualization course. We've looked at a number of key areas across scale, performance, density, where we've looked at dynamic memory, the impact of NUMA, the scalability numbers for Hyper-V and Windows Server 2012 R2. We've looked at how we can enhance performance, what the performance of some of our workloads is, how we can control resources and optimize efficiently. We've looked at the virtual switch and how we can stay secure through isolation, through some of the inbox and extended capabilities through some of our partners. And we briefly looked at BitLocker for encryption. We looked at running Linux. We looked at the different live migration and the speeds that you can now achieve through the innovative live migration capabilities that have been introduced in 2012 R2. We looked at what network virtualization could provide as a flexible way to deploy and manage networks more efficiently. Then we moved on and looked at resiliency, both at clustering, guest clustering with the new shared VHDX capability. We looked at some of the other mechanisms around resiliency, failover priority, affinity, anti-affinity. We looked at preferred and possible ownership, and then we moved on and looked at some of the other key capabilities about making things resilient across sites. Replica, extended replication, Windows Azure Hyper-V Recovery Manager, to name but a few. And then we finished by looking at just some of the extra bits, some of the other cool stuff that's in Hyper-V around Gen 2 virtual machines, around enhanced session mode, and finally around the automatic virtual machine activation. All in one package. A huge amount of innovation. That's why it takes us 3 hours to tell you just what's in Hyper-V, outside of the rest of Windows Server. This is a more complete virtualization platform that's really going to enable you in a cost-effective way to deliver comprehensive capabilities to the rest of your business, to your consumers, your internal customers, your customers if you're a service provider. So thanks for your time. We want to make sure that we're providing you with lots of useful information, lots of cool resources that you can use to help you evaluate just what some of these capabilities can deliver for you. So go check them out. Go evaluate what's on in Windows Server 2012 R2 outside of just virtualization. But start with virtualization because that's the cool bit, as we all know collectively. Check out the other courses on the Academy. There's courses for storage, there's networking, there's System Center, there's management. There's all sorts on there that you can benefit from. And if you get trained, if you get certified, you can become a real asset to your business, or if you're a partner, to your customers by passing on that knowledge, that guidance to deploy some really complex and cool and innovative infrastructures built on Windows Server 2012, managed R2, managed by System Center 2012 R2 as well. It's been a pleasure talking to you over the past few hours. If you haven't checked out the previous parts, check out part 1 and part 2. They're all available on the MVA now. Leave some feedback. Rate our courses, give us all the relevant information and feedback. We want to help you do as much as you can with the technology. And with that, thank you very much for your time, and I hope to see you again on another MVA course. So thanks very much.